Hello, my name is Henry Emphrey, and this is a Raylib game development tutorial. Now in this tutorial, we're going to make an enemy that walks around, and there will be some basic AI attached to this enemy that would allow the enemy to follow the player around, and we're going to set up a collision system so that you can defeat the enemy by projectiles or by shooting. And the reason that we're using sprites is instead of those flat shapes like just rectangles, circles, and flat shape like those. I'm sure many of you are interested in making those kind of games that you'd see on the Sega Genesis and Super Nintendo and old arcades and or maybe your iPhone and those kinds of 2D games that you usually play, right? So that's why we're using sprites. So what you're looking at now is I'm in paint.net. And if you've been watching these series of tutorials, I'm sure you figured out that this is just that the player has an evil brother. Yes, this is just a player character, and all I did was I just took his character and just painted his pants red, like so. And I did that for all the frames. And then after that, it will look like this. And then I click File and Save As. And then we're going to name it Henry Enemy, because it's me against myself. So the player is going to be fighting himself. Okay, so that's how we made the enemy. Let's go ahead and go back to our game setup. Okay, so in this tutorial, we're just going to keep it simple and just deal with one enemy. You can always take what you learned in this tutorial and create more enemies using this method or using a more condensed method, whatever you want. So we set up our enemy amount right here. So we're just going to have one. Okay, so let's go down, and these are just the notes that I wrote. You can stop the tutorial and read these if you want to, but I'll just tell you. Okay, so now we're at the enemy type or class or whatever you want to call it. Type class means the same thing in computer programming. So first of all, in this tutorial, we're going to cover two different methods of being able to defeat our enemy. The first method is going to involve this Boolean variable called active. And this variable, as long as this Boolean variable is set to true, then our enemy will be on screen, it'll be walking around, it'll be following the player. But once this active variable is set to false, the enemy will disappear off screen and won't be following the player or moving around the screen anymore. It'll just disappear and you won't see it, and it'll be gone. But the second method I'm going to introduce is one of my favorite methods. It's the concept of recycling the enemy. And this is my favorite method because it kind of makes the game run more fluid. It saves computer memory and it'll free up all the things that your computer has to do because your enemy's already loaded and created and everything. I guess when you make a big game, this could make a difference. But recycling the enemy has to do with, instead of deleting the enemy altogether, after the enemy is shot or zapped, it goes off screen. And the way we got our code set up is if it's shot by the right bullet, it'll go 1,000 pixels off screen to the right. Or if it's shot by the left bullet, it'll go minus 1,000 pixels off screen to the left. So with the recycling method, the enemy will still disappear. The only thing it will be doing is just going off screen. And this rectangle, this enemy frame rec, if the enemy's like, let's say, walking to the right, well, this enemy frame rec will hide the other frames and will retain only the frames dealing with just walking to the right. For example, a right walking frame animation is going to deal with just these two animations right here. Instead of 1, 2, 3, 4, 5 like us humans count, the computer starts with 0 when it counts. So it does 0, 1, 2, 3, 4, 5. So enemy frame rec does, it just makes it so you just dealing with what the computer would call 0, 1 and not these other frames. It hides the rest of these frames. So that's what the enemy frame rec is for. And then we got enemy collision rec. See, the bullet will be colliding with not the enemy sprite itself, but it'll be colliding with this rectangle that we will put around the enemy. And if the bullet hits this collision rectangle, that's what causes the enemy to be defeated and activate the active variable, or it'll disappear off screen via the recycling method. So enemy position, this is where the enemy would be on screen. We got enemy frame counter. This is like the engine that makes our animations run. Enemy frame speed, that's how fast our animations are going to be going. And enemy current frame, this keeps track of which animation will be used whenever the enemy is going to the right or walking to the left. And finally, we create a variable for this class here, and we call it enemy. And this variable just stores all this information up here. Isn't it amazing how computers can just take like one variable, let's say even it's just this little letter here. That one letter will store all this stuff. I think that's amazing how computers do that. But anyway, that's what this enemy variable does. Okay, so now we're going down. And here we're just kind of renaming that variable and creating an array, because we're going to use a for loop for our enemies. And this enemy amount is what's going to store the enemy array. Because I like to create for loops for my enemies. I'll talk about this more in a minute. And this stores where the enemy is going to start at on screen when our game launches. This detects whether the player Henry or the enemy has collided. And if the enemy collides with the player, the enemy won't be able to move. So this is the initialization part. This is just setting up the screen for when we launch our game. And one thing I like doing is I like to put my enemies into a for loop. It just makes it easier in case I want to duplicate my enemies. All I got to do is just add a number or add a variable or something to the for loop, and we'll have more enemies on screen immediately. And it's just another way just to get the for loop out the way. Just my preference. When dealing with for loops, I like to use words like all or any. Even though we're dealing with just one enemy, whenever you wrap a for loop around, whether you have just one enemy or not, it refers to all of the enemies. All the enemies have an enemy position, all the enemies have a frame rec, all the enemies have active variable, etc. Okay, so at this for loop, we're initializing our enemy's position and where it's going to start on screen once our game is launched. Remember, we put these enemy X and enemy Y. We said that the enemy is going to start at 100 from the left and at 290 in the vertical coordinate on screen. So we're just taking these variables and putting them here. I mean, technically it just says 100 and 290, but instead of putting regular numbers, we just use variables. And then we initialize the frame recs, where the frame rec is going to start and how wide and the height is. Remember, the frame rec is what hides the other frames whenever the enemy is walking to the right or walking to the left. It just hides the other frames that we don't need. And the way that I got this width and height is in paint.net. These are just individual frames. I took these individual frames from these individual slides right here. You got the walking right, and then you got the walking left. And at the bottom, you can see that each frame is 70 by 111. See? 70 by 111, each one of them. So that's what I put here. Just take the size of one of them and then put it here. And actually set the truth, because when the game starts, we're going to have our enemy walking around. It appears after being zapped, blasted, or shot. This actor becomes false and it disappears. Our frame counter starts at 0 and will be incremented depending on the animation that the enemy is on. Frame speed is going to be at 8. This is how fast our animation is going to be going, and any current frame, this just keeps track of which frame the enemy is on whenever it walks to the right or when it walks to the left. Here we're just inserting the sprite sheet that we talked about earlier. You remember this thing that I made in paint.net, and we called it Henry Enemy? We're just inserting that right here so we can use it later. And we're giving it a variable called enemy. And we just made this particular rectangle just so that we can use this enemy width part so that it'll work in concert with our enemy frame rec. And this is another thing that helps hide the frames that we're not using when the enemy walks to the right or walks to the left. Make things look more natural. Okay, so that's that. Okay, next we create a collision rectangle for Henry, so whenever the enemy gets close to Henry, it'll stop at a certain proximity. This is what detects whether our enemy and our player has collided. We had to use a for loop because whenever we're dealing with our enemy, since we started with a for loop, we use a for loop throughout, especially when we're dealing with our class variables. See, that's one of our class variables. So we're attaching this class variable to a for loop. So this says whenever any of our enemies, and as of now we're just dealing with one enemy. So remember, one enemy. So if our one enemy's collision shape collides with Henry's collision shape, then that will be counted as a collision, and that will make our enemy stop. And we set that up down here. We'll get this hit signal right here. Whatever frame is on, it won't go past what the computer will call third frame. See? Again, us humans count as 1, 2, 3, 4, 5, but the computer starts with 0. So the computer will call this 0, 1, 2, 3. You shouldn't see this frame right here, because this part prevents that. If it goes above third frame, see, third frame right here, it will just stay at that frame. Okay, so that's the collision between our player and the enemy. Okay, so here we're attaching the collision rectangle to our enemy's position right here. So all we're doing is just making it so that the collision shape covers and follows the enemy and covers the enemy. And once again, we're using everything that's in class variable that we set up here. Remember? Okay, so and then this next for loop has to do with just the enemy movement. So this for loop says if the enemy is active, our one enemy, and Henry and the enemy are not colliding, then if that is true, if Henry is in front of the enemy, then the enemy will move to the right towards Henry, because plus X in computer programming means going to the right, and it will go towards Henry at 1 pixel per second. And while the enemy is moving, our frames will be incremented, and between 60 divided by the enemy's frame speed, which we set to 8. Remember? We set it to 8. So technically this says our animation will go at 60 divided by 8 seconds. But instead of putting 8, we variable called enemy frame speed. So that's how fast our animation will be going. And while the enemy's animation is playing on 0, this is what the computer calls 0. We call this 1, but the computer calls it 0. And then this says if the current frame increments to 1, then it'll go back to 0, given that rightward walking effect. That is, again, if the frame starts with 0 and increments to 1, and it'll just get at 0, 1, 0, 1, 0, 1, 0, 1. Rightward walking animation, just like we talked about with the player. This is the exact same stuff with the player. And this last part just helps hide the other frames that has nothing to do with the enemy walking to the right. And do you see this enemy dot width divided into 5 part? Here is when we incorporate this rectangle that we made here. This is like one of the only uses that we'll use throughout our entire code, is just for this width part right here. And this is when we incorporate that part. This part is what helps us hide the other frames so that when the enemy's walking to the right, it won't look weird. Okay, and then always make sure that you close all your respective brackets and put all your proper punctuation. That's very important in programming in C or C++ or any of these kind of languages that uses brackets. Okay, so that's our rightward walking. And our leftward walking, of course, is the same thing. We again got the for loop. We attached all of our enemy class variables to this for loop here via this I that we have here. So this again says if enemy is active and hasn't not collided with Henry the player, then if Henry the player is behind the enemy will walk towards the left. X and minus means left. And while the enemies move to the left, our frame counter will increment at 60 divided into 8. But instead of 8, we put this enemy frame speed variable here. Remember? 8. And while the enemy's walking to the left, it'll start on 2. The computer will call this frame 2 right here. It's not frame 3 like us humans would think. The computer calls this frame 2 right here. And it just keep increment. And then when the increments to 3, every time the frame increments to 3, it'll go back to 2. When it gets to 3, it'll go back to 2 and giving that 2, 3, 2, 3, 2, 3 walking effect, just like the player, and giving that left foot walking motion. And then this part hides the other frames. And once again, we use this enemy width divided into 5 that we talked about up here. Once again, don't forget to close all your brackets. Otherwise, you'll get errors in your game. This has to do with our zap or shot. This has to do with the rightward bullet. And in this rightward bullet section, we have 2 for loops. One for loop dealing with the shot and one for loop dealing with the enemy itself. So this says if any bullet is active, because remember, whenever you have an I or some kind of letter within this for loop in this part here, I call that any. So this says if any bullet is active and any of our enemies is active, we don't have many, we're just dealing with one enemy. But since it's in the for loop, we're saying any. If one of our round bullets happen to collide with the enemy collision shape, or in our case with our one enemy, then that bullet becomes inactive, or that bullet's activity is set to false. That bullet's lifespan becomes 0, and that particular enemy, or our one enemy, active is set to false. That's what makes our enemy disappear, where the enemy will be gone from our game for good. That's what this part does. And same is true with our leftward bullet. We got 2 for loops here too. This says if any of our shots are active and if any enemy is active, which is our one enemy, and one of our bullets, our round bullets, happens to collide with our enemy collision rectangle, then that bullet becomes inactive and disappears. Our enemy's lifespan becomes 0, and our enemy active becomes false. That's when the enemy disappears, and it's gone for our game for good. So, this is how you defeat the enemy. Once again, later on, I'm going to show you a different way of defeating our enemy with a recycler method. That comes later once you see how this works. Here we're just drawing our enemy onto the screen. We put the texture that we set. You remember our texture here? See, we gave the texture a variable called enemy texture right here. So we just taking this variable here and putting it here so that we can see our enemy. Then we put in our enemy's frame rec which hides the other frames that are not being used. And this is our enemy position. Again, it's going to start at, remember, 100 on the x-axis and 290 on the y-axis. So we're drawing that here. And white is going to make our enemy frame rate transparent so that our enemy won't look weird when it appears on screen. Otherwise, if you put blue here, our enemy will be blue once you see it. And this part says whenever the enemy and the enemy collides, we're going to get a message that says hit. And it's going to start at these coordinates right here. In the background of it will be transparent too. And then our enemy won't go over what it calls third frame here. See, 0, 1, 2, 3. according to the computer. It's not what we as humans call the fourth frame. It's what the computer calls the third frame, as in 0, 1, 2, 3, which is the way computers count. So you shouldn't see this frame right here, this last frame right here. At least I hope it does. So whenever the enemy is stopped, it won't go to the last frame, which is frame 4. Again, make sure all your respective brackets are closed. Then finally, we unload our enemy once we close our game. And then don't forget this last stuff too. Make sure you had the punctuation, return 0 statement, and always close your brackets. Okay, so that's the code. I hope you all understand how it works. So let's launch our game and see what happens. So, there goes our enemy. Hey, brother, let me tell you something, brother. No, I don't want to hear it. Okay, so let's see if our shot works. Let's see what happens when we zap our brother. Okay, so our zap worked. Good. So that was the leftward bullet, or zap. Let's try the rightward bullet. Try again. Okay, here we go again. Hey, brother, let me tell you something. No, I don't want to hear it. Okay, so here, rightward bullet. Okay, so the rightward bullet worked. You know what? I don't really feel right calling it the enemy because it's all me. Both of them are me. It's like me shooting myself or something. I feel right calling it bullet. I feel like calling it because it's me against myself. Okay, so our rightward bullet worked. Okay, so now I'm gonna go back and show you a different method for defeating our enemies. That recycle method that I talked about earlier. So let's go back to our. This is our rightward bullet. So I'm going to comment this part out, and then I'm going to uncomment this part. This is our recycle method now. Okay, so this is my favorite method, which is the recycle method. And we're going to do the same thing for this part. Okay, so now next time our bullet hits the enemy's still going to disappear, but it's going to do is just go off screen somewhere and come back. Okay, so let's try this now. Okay, let's see what happens when we blast our enemy. We're going to start with the leftward bullet first. Okay. Alright. So, now let's see what happens. See if it comes back. Okay, so my brother's gone now. Hey, brother. I just wanted to come back and tell you something. I think I can have fun with this. Okay, so our right bullet worked. So, and you can see our AI is working, and you can see that our enemy's following the player. That's what we wanted. Okay, so let's see if our leftward bullet worked. Try again. So let's see if he comes back. Hey, brother, you know what? I forgot to tell you something. I want to tell you something else. So I blast him again, and he's going to come back again. And as we can see, the rest of our game is still working. Our platform's working. The grass is working. We just went from day to night. Our floor platform is working. So that's our recycling method. You can just take some of the methods that we use and just create a whole bunch of enemies like that, and they just keep recycling and coming back as if they're a new enemy. I mean, some of y'all can just go ahead and make our games right now with just the methods that we talked about. And you don't have to just recycle enemies. You can keep recycling raindrops, or keep recycling clouds, or keep recycling cars, keep recycling people, and other stuff that's in your background. You can just keep making a game just like this. Other than having scrolling backgrounds, this is the way I used to make my games for a long time. My motto and the philosophy that I follow in computer programming is do what works. Because you gotta do what you gotta do. So, I hope you learned something in this tutorial. Take what you learned in this tutorial and expand on it. Until next time, thanks. Bye.